Okay, so we're going to try to remember everything that we discovered last class, which was a lot, right? We discovered a lot of things about transformations, and the final summary of what we learned was here in number 6 from the previous class. Does everybody have the notes, by the way? Was anyone not here? Hold on. Okay, so this was the summary of what we learned. When you make transformations, when you make changes to a parent function's equation, when you make changes to the formula, if you add or subtract, that's going to lead to a shift, up, down, left, or right. Okay. If you multiply, that's going to lead to a stretch or a shrink, a vertical stretch or a shrink, or a horizontal stretch or a shrink. And negatives lead to reflections. And then the question of whether it's a vertical or a horizontal change to the graph depends on whether you made an inside change or an outside change to the formula. Inside changes or changes to the input result in horizontal changes to the graph, and those changes are always the opposite of what you'd expect. And outside changes or changes to the output of the function result in vertical changes to the graph, and those changes are generally exactly what you would expect. So this is how I remember it. You are welcome to also just memorize this table. It just feels like more to memorize to me. So you can do it either way. So what we're going to do is take those things and we're going to apply them to the graph of square root x. We're going to do some transformations of the parent function square root x. So I have the original parent function graphed here. And I want to sketch a graph of y equals the square root of x minus 4 by hand. So let's think about what kind of change I made to the equation. Is it an inside change or an outside change? Inside, because it's inside the square root, right? I'm changing the x minus 4 before I square root. So it's an inside change, which means it's going to be horizontal. Okay, so something horizontal is going to happen. I'm subtracting 4, and when you add or subtract, that leads to a shift, right? So I've got a horizontal shift. Which direction do I go? To the right, yes, because horizontal changes always lead to changes that are counterintuitive, right? So negative, your intuition would tell you go left, but anytime you have an inside change, you do the opposite thing. So we're going to go right 4 units. So I'm just going to jot down in English what this says. This says, do a horizontal shift right 4 units. So it can really help to translate what that equation says into the language of transformations before you start trying to sketch. So if you look at that and you say, okay, that means I should go right 4 units. So you can either picture your graph moving right 4 units, right? Just slide it over 4 units. But if you're not good at visualization, you can also do this by points. So if I pick a point like 0, 0, moving to the right 4 units is going to increase my x coordinate by 4. So you could just pick a few key points. There's 1, 2, 4, 2. Right, so pick a few key points, and all of their coordinates, like this would be 1, 1, and this is 2, 4. Every x coordinate is going to get 4 added to it. That's how you shift 4 to the right. So my new function, instead of 0, 0, is going to be at 4, 0. And instead of 1, 1 is going to be at 5, 1. And instead of 2, 4 is going to be at 6, 4. Oops, that's 4, 2. That was stupid. Hold on. That's the point 4, 2. Okay, and then start again. Okay, 0, 0 goes to 1, 2, 3, 4, 0. 1, 1 goes to 5, 1. 4, 2 is going to go to 8, 2, right? Add 4 to the x coordinate. So that's 1, 2, 3, 4, 5, 6, 7, 8, 2. There we go. And then I can sketch my graph. And if you need another point, you can always do another point. I have 9, 3 is on my original. And if I go 4 to the right, that's going to go to 13, 3. I messed this one up. This is supposed to be at 4, 2, and I put it at 4, 3. I mean 8, 2. There we go. Okay. So I took each of my points and I moved them 4 to the right by adding 4 to the x coordinate. So then I connect them. And there's my graph shifted 4 to the right. All right, so what do you think of that? Kind of okay? So once you decide what the transformation is that's happening, drawing it isn't so hard, right? So it's the translation from the equation to like the English of what's going to happen to the graph. And then we can say, oh, it's a horizontal shift 4 units to the right. That means increase every x coordinate by 4. So maybe I'll write that down too. All right, let's take a look at the next one. This time I'm graphing the square root of x minus 4. So is this one an inside change or an outside change? Outside, yes, it's outside of the square root. So that's an outside change, which means I'm going to have something vertical happen, right? It's minus, which means it's going to be some kind of a shift, plusing, adding and subtracting are shifts. It's minus, so which direction am I going to go? Down, yes, because vertical shifting is always exactly what you expect. All right, so this is a vertical shift. Vertical shift down 4 units. Okay. Which means if I want to take a point and move it down 4 units, how am I going to change the coordinates of that point? So for example, 0, 0. If I move it down 4, where's it going to land? 0, negative 4. 0, negative 4. Let's make a different color. It's going to move there. So what happened? I took the y coordinate and I subtracted 4. So when you move a point down 4 units, you end up subtracting 4 from the y coordinate. So you could also write subtract 4 from every y coordinate. So you could pick a few key points like 4, 2, and 9, 3, and 1, 1. And then I'm just going to subtract 4 from every y coordinate. So if I take, for 1, 1, when I take 4 away from the y coordinate, I'm going to get 1, negative 3. So I can go down 4, 1, 2, 3, 4, and I land at 1, negative 3. And 4, 2 is going to become 4, negative 2. And 9, 3 would become 9, negative 1. Took every point, moved it down 4. And what that causes is the y coordinate to decrease by 4. All my y coordinates decrease by 4. And then if I connect those, nice smooth curve, it looks just like my parent function, but shifted down 4 units. So some people are more visual and like to just picture this whole thing moving down 4 units and draw it. Some people are more numerical and like to do the points and subtract 4. So whichever way makes more sense to you. You might do a combination of both. You might lean more one way than the other. Whatever feels natural. All right, let's look at 2 times the square root of x. Inside change or outside change? Outside. It's outside change, so this is going to be vertical. Okay. How am I changing? I'm multiplying. Good. So when I multiply, that's either going to be a stretch or a shrink. In this case, is it a stretch or a shrink? It's a stretch because I'm multiplying by 2, multiplying by a big number, right? And you imagine that when you multiply by 2, things will get bigger. That would be your intuition. And with vertical outside changes, you follow your intuition. So this is a vertical stretch by a factor of 2. So that means I'm changing my y coordinates, right? I need to take every y coordinate and double it. That's how you cause a vertical stretch by a factor of 2. You multiply every y coordinate times 2. So pick a few key points. 9, 3, that's good. Okay. And I have 0, 0, 1, 1, 4, 2, and 9, 3. To cause a vertical stretch, I'm going to take each y coordinate, because y's are the vertical part of a point, and double it. To do a vertical stretch by a factor of 2, take each y coordinate and double it. So 0, 0 is going to go where? It stays at 0, 0, because when you double the y coordinate of 0, it's still 0. Okay. Where's 1, 1 going to go? 1, 2. Double the y coordinate. Okay. And 4, 2, where's that going to go? 4, 4. And 9, 3, that would go to 9, 6. Good. So then we connect those. And there is a graph of the square root function stretched vertically by a factor of 2. All right, any questions so far? All right, let's look at D. The square root of 1/2 x. Inside change or outside change? Inside, that's inside the square root, which means it's going to be horizontal. Is it a shift or a stretch shrink? Stretch shrink because it's multiplication. Is it a stretch or a shrink? Stretch. This is a horizontal stretch because you'd think that multiplying by 1/2 would make things smaller, right? But because this is a horizontal inside change, it does the opposite and it stretches. Okay, so this is a horizontal stretch by a factor of what? 2. Yeah, it's the reciprocal of that 1/2. Yeah, so it's by a factor of 2. Okay. So if I want to stretch horizontally by a factor of 2, that means I'm changing my x coordinates, right? Because I'm doing some kind of horizontal change. My x's are changing. And I'm stretching them. That means I'm going to double them. So I'm going to multiply each x coordinate by 2. So I've got 0, 0, 1, 1. I should really add these to the notes so that I don't have to draw them every time, huh? 4, 2, and 9, 3. And I have to double my x coordinates. So that's how I cause a vertical stretch. Multiply the x coordinates by the factor. So 0, 0, where does that go? Stays at 0, 0, because when you multiply the x coordinate of 0 by 2, it's still 0. 1, 1, where does that go to? 2, 1. Doubling the x coordinate leads you to 2, 1. How about 4, 2? Where does that go? 8, 2. 8, 2 is right there. And 9, 3, where is that going to go? 18, 3. So this is a horizontal stretch by a factor of 2 of the square root function. Oh, that was a little wobbly. Sorry. It's not much better, but a little bit. Yes, Sabine. It's, yeah, I know. Yeah, so right, so that means it's going to be a stretch, right? You see this 1/2 times x, and your intuition says that this should be a shrink, right? Because multiplying a number by a half usually makes that number smaller. But because it's an inside change, it's the opposite of what you think. It's actually going to be a stretch. So to, yes, same principle as the plus minus. Yep. So multiplying, so when you're inside, if you multiply by a small number, things actually get bigger. You multiply by a big number, right? If that was a 2, things would actually get smaller. So they get smaller or bigger by a factor of the reciprocal of that number. So I just flipped it over, and that's how I got the factor of 2. So this is 8, 2, and 18, 3. So we doubled all the x coordinates. And it's easy enough to double check that we did this right, right? I just want to make sure, let's say 8, 2 is on the graph. Go back to your equation and plug in an 8, right? Well, yeah. We can plug in 8, 2 and see if this equation's true, right? Is that true? Yeah. 1/2 times 8 is 4. The square root of 4 is 2. 2 equals 2. Check. Right. So you can always take a point that you found was on your graph by using transformations, plug it into your original formula, and see if it's true. All right, let's look at E here. The negative square root of x. Is that negative inside or outside? Outside. So that means it's going to be a vertical change, right? And negatives are reflections. So a vertical reflection would be over the x-axis. Yeah. If I create a vertical reflection, it would be over the x-axis. Yeah, so pick a few key points here. So I've got 0, 0, 1, 1, 4, 2. Yeah. So what I'm doing is, because this is an outside change, which is a vertical change, so I should write this down first. This is a vertical reflection. That is over the x-axis. Okay. So the way you reflect vertically, right, because it's an outside change, I'm changing y values, I need to take the opposite of every y value. Make every y value negative. Negative. Yeah, because that's what multiplying by -1 does. It changes the sign to its opposite. Yep. So here's my my few key points again. I'm just going to take every y value and take its opposite. So 0, 0 stays at 0, 0 because 0's opposite is 0. And 1, 1 becomes 1, -1. 4, 2 becomes 4, -2. 9, 3 becomes 9, -3. And then you connect them. And it's a reflection of the parent over the x-axis. Okay, last one. That negative, is that inside or outside? Inside, which means we have a horizontal reflection. So if you think about what a horizontal reflection would look like, it would be over the y-axis. Yes, which means make all the x's negative. Good. So 0, 0 will stay where it is because the opposite of 0 is still 0. 1, 1, 4, 2, 9, 3. Okay, so I make x values negative, 0, 0 stays there. 1, 1 becomes negative 1, 1. 4, 2 becomes negative 4, 2. And 9, 3 becomes negative 9, 3. There we go. Reflection over the y-axis. Oops. All right, do you feel like you're starting to get a grasp of what the rules are for transformations? Oh. So what does your intuition say? So it would stay the same? Well, that can't be, right? Because I changed the x's. Yeah, so I guess that there's an exception to that rule with reflections. Yeah. Because really you're multiplying by negative 1, right? And so if I was multiplying by negative 2 on the inside, that would be a shrink and a reflection. So the fact that it's a 1 means that there is no stretch or shrink. Does that make kind of, oh, okay. Okay, so the next thing we're going to talk about is what happens if you have more than one transformation. So more than one change to my function. So a function that involves more than one transformation can be graphed if you do the transformations in this order. Okay, so you do any horizontal shift first, then any stretching or shrinking, and the order doesn't matter, vertical, horizontal, whatever, stretching or shrinking, reflecting, and then vertical shifting last. It has to do with the order of operations. And it has to do with the way that we write the function. So these steps work if the function is written like this. You know, y equals a times f of bx minus c plus d. So it has to do with the order of operations. You want to do the horizontal shifting first, because that's in the parentheses, right? Then you do stretching and shrinking, the other thing in the parentheses and the multiplication outside, because you do the multiplication next, and then the vertical stretch, the last thing you would do in the order of operations. Reflecting, yeah, you do reflecting. It's kind of in the same step as stretching and shrinking because it's also multiplication. Yeah. If the order is different, if I were to rewrite that a little bit, if you factor out the b, if you factor out this term here, the order is a little bit different, but your book does it this way, so this is how we're going to stick to it, just so that it's not, we don't confuse ourselves. All right, so I have a piecewise function, k of x. First, in your groups, take 5 minutes and just graph k of x. So graphing a piecewise function is something that we've learned how to do. Graph this on the axes on the left. Okay, let's graph the piecewise. This says that if x is between 0 and 3, you graph the function y equals 3, which is a horizontal line at a height of 3. Okay? So from 0 to 3, including the 0 but not the 3, I graph a line that has a height of 3. Not the 3. Horizontal line at 3. All right, and then from 3 to 6, I graph the line negative x plus 6. So if I plug a 3 into that formula, negative x plus 6, what do I get? 3. Okay, so that fills in my circle, right? Because now 3, 3 is on my graph. And if I plug a 6 into that formula, what do I get? 0. So I plot 6, 0. And I know that this is a line because I recognize it as mx plus b format. So these are just connected with a straight line. Okay, so that is my original k of x in purple. Right. Now I want to graph a transformation of k of x. And this formula involves 1, 2, 3, 4 different transformations of k of x. And I have to follow the order that we said to do for multiple transformations, right? Horizontal shift, stretching and shrinking, reflecting, and then vertical shift. All right, so the first thing I want to do is the horizontal shift, which is right 1 unit. Okay, so first thing I want to do is, looking at that equation, jot down what the transformations are in English. So maybe I'll do that on a separate page here. So I have negative 1/3 k of x minus 1 plus 3. Okay, so my horizontal shift is right 1. Okay, so you always do the horizontal shift first. Then you do any stretching and shrinking. Are there any terms in that formula that lead to a stretch or a shrink? Yeah, the 1/3. That 1/3, it's multiplication, right? 1/3 times k. So it's multiplication. It's going to be a stretch or a shrink. Is that outside or inside? Outside, which means it's vertical. So I've got a vertical stretch or a shrink. Shrink, yes, because it's outside. It's exactly what you expect. That's a small number. It's going to make things smaller. So this is a vertical shrink by a factor of 1/3. Right, the factor just stays exactly the same when it's vertical. Nope, I would say 1/3. And then I'm going to treat the negative as a reflection after I've done the shrink. So this is my first step, horizontal shift right. Second step is the vertical shrink by a factor of 1/3. Third step is going to be to reflect. That negative is going to be a reflection. Is that negative outside or inside? Outside. It's outside the parentheses, so that means it's over the x. Vertical is over the x-axis. Reflect over the x-axis. Okay, and then the plus 3 is the last thing I do, and that tells me to do what? Up 3. Yeah. Shift up 3. So those are my 4 steps. I'm going to draw them in 4 separate increments. It's hard to do this all at once. So shift right 3 means add 1 to the x values. Okay. A vertical shrink by a factor of 1/3. What do I do to the coordinates to make that happen? Divide the y's by 3 or multiply them by 1/3. Multiply y's by 1/3. Oops. Reflect over the x-axis. What do I do to the coordinates to make that happen? Make the y's the opposites. Good. And then how do I shift up 3? What do I do to the coordinates to make that happen? Add 3 to each y. Add 3 to all the y's. Yeah. If you prefer and to get some graph paper and do these separate, you know, one on each on a different grid, that's totally fine. I just didn't give you enough. I didn't give you any extras here. Okay, so the first thing I do is my horizontal shift. I'll do that one in pink. So I'll do a different color for each one so we can keep track. So my horizontal shift was 1 to the right. That was add 1 to every x coordinate. So let's just look at my key points here. I've got 0, 3, 3, 3, and 6, 0. 3 key points. I'm going to move them according to each rule that I did. So if I want to move right 1, I should add 1 to each x coordinate. So I'm going to have 1, 3, 4, 3, and 7, 0. So I just shifted the whole graph 1 to the right. Okay, so then the next thing I'm supposed to do after my shift to the right was a vertical shrink by a factor of a third. And that is, to make that happen, multiply all of your y's by 1/3. So I go back to my graph. I'll do this one in blue. Take each y coordinate and multiply it by a third. So 1, 3, what does that become? 1, 1. 4, 3, what does that become? 4, 1, yeah, which multiply the y coordinate by a third. And 7, 0, what does that become? Still 7, 0, because when you do the 0 times a third, it's still 0. Okay, so now I've done my vertical shrink, and it's teeny tiny, right? Next thing I want to do is my reflect over the x-axis. Make all my y's opposites, reflected over the x-axis. So I'll do that one in green. Maybe I should put the points in here. This is 1, 1. That's 4, 1. That's still 7, 0. Okay, so now reflect over the x-axis. Instead of 1, 1, I'm going to have 1, -1. Taking my y coordinates and making them all opposite what they are. So instead of 4, 1, I get 4, -1. And 7, 0 stays 7, 0, because when you take the opposite of 0, it's still 0. So here's my reflection over the x-axis. And then let's see, the last thing I'm supposed to do is shift up 3. So add 3 to every y coordinate. So I'll put these coordinates in here. I've got 1, -1, 4, -1, and 7, 0 still. Okay, so final step is to take that green function and move it up 3 units. So add 3 to every y coordinate, and I'm going to get 1, 2, 4, 2, and 7. When I move that up 3, that's going to land at 7, 3, right? 7, 1, 2, 3, 7, 3. So this purple graph is the final one. That's the final answer. Everything else was just a step to get there. I mean, if you can do them all in your head, you can. Yeah, it's fine. Or you want to try one? So like we did in the last one, it's very helpful to write down what all the transformations are and what that means for your coordinates before you start trying to draw.